Hi guys, and welcome back to Maths with Cats. So today we're going to be going over binomial expansions for AQA A-Level Maths. So the first thing we're going to go over is Pascal's triangle. Now, if you've never seen it before, you'll have no clue what I'm going on about first, but it will make sense by the end of the slide. So if we expand 1 plus x to the 0, well, anything to the power of 0 is 1. So we get this. 1 plus x to the power of 1, anything to the power of 1 is itself, so 1 plus x. 1 plus x squared, we should be able to do this easy. 1 plus 2x plus x squared. 1 plus x cubed, you might need a table for this, you might not. 1 plus 3x squared plus x cubed. 1 plus x to the 4, you probably need a table. 1 plus 4x plus 6x squared plus 4x cubed plus x to the 4. Now, why am I showing you this? Well, how could you expand this, but with a really big number? You probably can't right now without it taking for ages. This is a method to use. So Pascal's triangle, you might not have noticed, but we'll just take out the x's for now and just use coefficients to make it a bit more obvious. 1 plus 1 is 2. 1 plus 2 is 3. 3 plus 3 is 6. So you're noticing the ones underneath in the middle of two numbers are the sum of them. And basically these are the coefficients. So for anything to the power of 0, use the top row. It's just 1. Anything to the power of 1. So basically if it's something plus something to the 1, the coefficient of the first term, 1, coefficient of the second term, 1. Squared, coefficient of the first term is 1, second term 2, third term 3, anything to the power, and so on. Okay, so 1 plus x to the n equals what? Now, there is a formula for this, so that if you have a really big n, you're not writing out Pascal's triangle forever. And that is this. 1 plus x to the n is equal to 1 plus nx plus n lots of n minus 1 over 2 factorial x squared, blah, blah, blah. This isn't the formula book, you have to know it off by heart. And if you don't know what factorial is, 2 factorial is 2 times 1. 3 factorial, 3 times 2 times 1. 4 factorial, 4 times 3 times 2 times 1. Does that make sense? Okay, so here's an example, and it might make this all make more sense. So, expand 1 plus x to the 20, given the first 4 terms in ascending powers of x. So to do this, our n here is going to be 20. So we're going to have 1 plus 20x plus 20 lots of 20 minus 1 over 2 lots of x squared, plus 20 lots of 20 minus 1 lots of 20 minus 2 over 6 lots of x cubed, and so on. We only want the first 4 terms. If we multiply it all together, you get 1 plus 20x plus 190x squared plus 1140x cubed. Write the fraction parts in form NCR, which can also be written NR equals n factorial, r factorial, lots of n minus r factorial. Again, looks a bit confusing, but to show it a bit more obviously, the same stuff up here can be written 1 plus 21x plus 22x squared plus 23x cubed. That's all that is. Okay, a plus b to the n. What's that? This one, again, this formula is in the formula book, can be written in a to the n plus n1 lots of a to the n minus 1 lots of b plus n2 lots of a to the n minus 2 lots of b squared, and so on. So here's an example, again, make it more obvious. So find the 4 terms in the expansion of 2 minus 3x to the 6 in ascending powers of x. So here our a is 2, our b is minus 3x, and our n is 6. So it's going to be equal to 2 to the 6 plus 6, 1, lots of 2 to the 5, lots of minus 3x, plus 6, 2, lots of 2 to the 4, lots of minus 3x squared, plus 6, 3, lots of 2 cubed, lots of minus 3x cubed, which is the same as 64 plus 6, lots of 32, lots of minus 3x, plus 15, lots of 16 plus 9x squared, plus 20, that's supposed to be lots of 9x squared, plus 20, lots of 8, lots of minus 27x cubed, which is the same as 64 minus 576x plus 2160x squared minus 4320x cubed. Now it's going to ask us to use this to estimate the value of 1.7 to the 6. Well, we have the to the 6 bit, and we want this bit, therefore, to equal 1.7. So we want to find the value of x where 2 minus 3x equals 1.7. Can rearrange, and you find out that x equals 0.1. So we're going to put 0.1 in where we had x in our expansion, and then if you expand all that out, you get 23.68. So 1.76, 7 to the 6 even, is roughly equal to 23.68. Here's another example. Find the coefficient of x to the 9 in the expansion of 4 minus 2x to the 11. So for this, we just need to find the power of 11 term. We don't need to expand it all out. So we're going to use 11, 9, lots of 4 squared, lots of minus 2x to the 9, which is the same as 55, lots of 16, lots of minus 512x to the 9, which is minus 450,560x to the 9. And that is it. So the coefficient will be minus 450,560. And that is it for this video. I hope you found it useful. If you have any feedback, leave it in the comments below. And if you found it useful, like, subscribe, share, all that stuff. And hopefully I'll see you in the next video. Bye bye!